Last time we created a simple application where we created a command, an interpreter, a parser, and we basically were able to run commands from the console. So let's just run the application and see how it works. So we can start it, right? We can put a value at key test, at key hello, and let's put a value world, right? And we can dump that value. And then we'll see that at key hello we have the value world. We can also put the value 2 at key 1 and put we can use any sort of strings. The only thing that we can't do is have keys or values that have spaces, right? We have a very, very simple parser. We just tokenizes by space. So we can do any sort of thing here. We can dump, right? And we'll see all the things that we've inserted. I think we can delete key 1, for example, and then it's removed, and then we can get a specific key and we'll get the value, right? And then we can exit, right? So that's all we can do. And we can easily see all of these things by just looking at the command type, right? So we have a put with a key and a value. We have a get with a key. We have a delete with a key. We have dump and we have exit, right? And I think I've showcased all commands. Okay, so how does this thing work? Let's go through it like really, really fast, right? So we have a store type, which is a list from with tuple, like from tuple to tuple, right? Sorry, from string to string, right? So each element of this list has basically 2 strings. The first string represents the key and the second string represents the value, right? So this is a pretty inefficient structure here because we don't have fast access or anything like that. Okay, so then we have the interpreter, which given a command and a current store will execute an effect and return the current store. The effect in the case of put is nothing, so we return a pure where we just update the store, right? With we add at this key this value in this store, so we get a new store. If the value already exists, we replace it. If it doesn't, we append it to the store. Get will just so this is why we need the effects, right? So this is why we need to return store, because we need to update it, and this is the only, this and delete are the only things that update, right? So this both return pure and then a new store. And then get, dump, and exit all need to run effects because they log things, and then they return the old store, right? And both get and dump return the old store, and they both log either a single entry if they can find it, or all the entries in the store. And then exit just quits the program, right? That's pretty much it. And all of these are just helpers, which are pretty much just pattern matches over lists, which basically just do pattern match, usually looking for a key and then doing something, right? Whether it's finding it, updating it, removing it, or grabbing all the data, and so on. Okay, then we have a parsing function. The parsing function goes from string to maybe a command, right? Because we might not have a command, right? We might not be able to parse it. And there's the easy ones with the exit and dump, and then the ones where we split by spaces. And we look for, okay, if we have get and a single key, then that's the get command, and so on, right? We parse everything, and then if all else fails, we just do nothing, which is, we were not able to parse, right? Maybe this is slightly more readable, I'm not sure. Okay, cool. And then we have the main function, which is slightly trickier. So okay, we create an interface, which is just some internal thing regarding the reading and writing the console. It is not very relevant. We start with an empty store, and then launch app is something like asynchronous code in some sense, right? Because this loop thing is something like you write something to the console. Well, this basically not this loop, but it's specifically regarding the question function, right? So the question function takes a string, which is the prompt, and then returns you a string, but this string, it doesn't happen this is whenever you hit enter on your keyboard after having typed something in the console, right? So it's an asynchronous thing, so it needs to run into F, right? So if you're familiar with JavaScript or whatever, this is kind of, it incorporates async await somehow, right? Into this monadic sort of binding here. Right, and then we can do we get a response after the prompt, and then for that response, we're trying to parse it. If it's nothing, then we say, hey, we could not parse the command, and we loop back into the same thing. Or if we were able to execute to find the command, then we interpret it and then go back with the new store, right? Because this is if this is put or delete, then it potentially changed our store. Okay, so there's a few things that we would like to change now. In terms of like just explaining and having a simpler interface, last time we've used lists here, and then we've done a lot of case matching and so on. Maybe it's obvious that this would be a lot better if it was a map, right? Because maps have faster access. They also guarantee that keys are unique, which is something that we are not guaranteeing right now. It's just that we have to trust our put functions to not, or rather our update store to not have bugs in it. But and then it's it's just the wrong structure to use, right? So let's use a map function, right? So in order to use map, we need to add, I think we need the, so let's see, let's make sure that I'm not wrong here. So let's look for the map type. I think it's in the containers. Well, it's order collections actually, is the name of the package that this is in. So let's grab that and add it to the list of packages that we are using. Okay, so we need to save this and then install. Build. I think it was already a transitive dependency, so this took absolutely no time at all. Let's start PSCID on the right hand side. Okay, cool. So that means that we can now do map, and then we can also import the map type here. And as soon as I pressed enter here, you might have noticed that we got this import here from string to string, right? Okay, so now the thing is, once we save this, we'll immediately get like one error, obviously, but there's several errors, but PSCID just shows them one by one, right? So let's see. Here it's telling us that okay, we are trying to pattern match over a list, but this is a map, right? So this doesn't work anymore. Okay, so let's see. We need a function, right, that given a key and a value and a map updates that map. It starts something like an upsert, right? So I think normally we should just look inside this data map module, right? We could look by the type, but then maybe we could just read this module a bit and like familiarize ourselves with what kind of things we have here, right? So we have an update, right? So let's see what kind of thing. Update or delete the value. So I don't need update or delete, I need update or insert, right? So this is not the thing we're looking for. Submap, no. Member map, maybe. Intersection, insert or replace, right? So I think this is exactly what we want, right? So insert given a key, a value, and a map gives us a new value. Okay, so this is given a key, a value, and the current map will give us a new map. So I think we literally just need to replace update store with m.insert. I will import things as qualified using m for map, right? So then we just don't need any of that anymore, and that should just work now. And we somehow accidentally moved this, right? Okay, so let's see, what's the next error? Well, it's saying for get data. I'm not sure why it's jumping to get data, but that's the next error that we're getting. And let's just fix them in order, right? So okay, what's get data? Well, this is a function from now it's a map stored to a list of strings, right? So the idea is we need to grab each key value pair from the store and kind of do this thing over it, right? Like first of all, we need to convert it to a list, and then we need to do this sort of like combining the key and the value. So let's see if we can find something in the list, right? So I think we probably need, oh, hello, welcome to the stream. So let's see, so this is like from foldable. We kind of need the opposite of from foldable, right? We kind of need to go from from our map to some f, tuple f, right? I see this part is on refactoring. Yeah, we're just refactoring some of the code we wrote yesterday. Nothing too fancy, just simple code that's fun to play with. So I think we need to find a two-foldable, right? So let's see whether we can find something like that. So two-foldable. Nope, there isn't here. So let's see. Maybe we have unfoldable. Is there? Okay, so two unfoldable, unordered. Or just to unfoldable. It leaks the underlying, making suitable for application where order is relevant. If you are unsure, yes. Okay, sure. Let's use this. So to unfoldable, so what it is? So given that f is unfoldable, we can go from our map to an f of the tuple of these two values. Interesting. So what's unfoldable? Let's have a look. So what kind of things are unfoldable? Well, by default, there's arrays are unfoldable, but let's see, maybe lists are also unfoldable. So the way to check that is usually you just search for the list type, and then we just click on the list type and see whether it has an unfoldable instance, and sure enough, it does have one, right? So we can definitely also use lists, like to use to unfoldable to a list, right? Hello Alex, welcome. I've seen you've also streamed, but I didn't get to look at your stream yet. I want to look at the VOD just to see what you're up to. Hopefully it was fun for you. So let's see. Cool. Okay, so let's see. We need to replace all of this with to unfoldable, right? So let's see. We just need to do to unfoldable, but we need to do the map to unfoldable, right? So we just need to do m.toUnfoldable, given the store map. It was more just chatting than programming. Cool. I mean, those are also very fun. So we need to do store, and then okay, so then we just actually, I'm not sure why I'm doing it like this, because this just results in a list of tuples of keys and value, right? So in order to get to that sort of thing, we need to also map something over it, right? So what do we need to map? Well, we need to map a function that, given a let's just do a go, right? Like a helper go function, right? So we can do where go is a function from tuple of string and string, goes to just a string, right? That's what we need to do. And then we can do tuple key value equals 2, and sure enough, we already have that code here. So we just need to clean this up a bit, and I think that should already work. Yep, we're getting a different error now, so we get to get data, but it's way simpler, right? It's just this. Okay, excellent. So now we have find key. So again, the problem with find key is that, well, store is no longer a list, so we need to figure out what we do with store right now. And obviously there should definitely be a find key in our for maps, right? So let's see if we can find it easily, right? So member just tells us if a key exists, right? But it doesn't give us the value, so that's not what we want. Maybe we want to use maybe it's called lookup. So let's see, look up a value for the specified key. Yep, that looks like what we want, right? So given a key and a map, we get a maybe value. Okay, so let's try doing that, right? So we want to do m.lookup, and then given some key, right? And a store or a map, but that's store for us. We maybe get a value, right? So how do we go from string to like what do we do with the maybe? Well, one way would be to do from maybe, and then give it a default value of no key found, and then run everything else there, right? So what does from maybe do? Well, given a default value a and a maybe a, you get back an a, right? So if the lookup fails, then this is the result, right? Otherwise we get the result of the lookup, right? So that's about it. That should work, which means that we are still using find key, but we only need it because we want to use this from maybe, right? We don't want to paste that code in here. Okay, and then we need delete key, right? So delete key is I'm pretty sure we should be able to find some remove or delete here, right? So let's see. Yeah, delete, right? So given a key and a map, we get a new map back. So again, that's pretty trivial. We just need to do m.delete here. And I'm pretty sure, and then we need to just delete this function, right? It's no longer needed, and we save. And yeah, we're literally done with all those functions. So now the problem is we're initializing our store with nil, which is a list, right? But then we're trying to pass it to loop, which requires a store, and now stores are maps, right? So how do we do an empty map? Well, I'm pretty sure there's an empty, there should be an empty here. Size singleton, pop member. I'm pretty sure maps should have an empty constructor, like not constructor, but helper somewhere. Let's see if we can, oh, there we go, empty, right? So it's just m.empty. This might, let's see if this works. Yeah, it does work. Okay, now we know we're doing it right because it's telling us that we no longer need list. Like, at least not the constructors. We still need lists, the list type, because we use it here when we're trying to get the data, right? Okay, cool. So it looks like it works. So let's run it for a bit and just make sure that it does work, right? So let's try the same thing. Put hello world. Put 1, 2. Put foo bar. Put whatever, and then just do dump. And sure enough, it works, although the order is different now, right? Because now things are actually in a proper container, which doesn't guarantee the order, but it does guarantee the fact that, well, actually, they are actually ordered, I think, which is, let's try putting 2, 3. So I think this time they're actually ordered, just because that's how it works out. Okay. I mean, that doesn't really matter. It's totally fine. So now we can do get foo, and we should get bar back, and then we could do delete SDF, and we can do dump, and then it's gone, and we could do get SDF, and it's no longer there, right? So everything still seems to still be working. So let's see if we have any other sort of refactorings that we could be doing. There are a few small things that we could do, like replace some operators, add some $sign instead of parentheses, but I don't think I want to worry about that too much. Maybe I'd like to do this just so everything is on 2 lines, and this as well. I think this looks a bit better and it's easier to read. We definitely need to actually create a real parser here at some point, but that's not something we'll worry about right now. Then there's this loop function, right? So we never use the return value of this function, which is a bit awkward, right? So I think we will just swap it to returning unit, because I don't think we actually need this. This means that we can discard this result, and I think it should just work if we only do this 2 changes. Yep, like that was initially we thought that we would feed loop into itself externally, but then we decided to just call it recursively ourselves, right? And we'll see if we do run into trouble doing that. So let's do a small, like a very quick test here. We'll not do just hello world and 1, 2, dump, and then I don't know, get 1, delete 1, get 1, dump. So everything seems to still be working. So I guess we did a good job with this minor refactoring.